Okay, what is a hyperbola? So we're going to find the center, vertices, foci, eccentricity, and equations of asymptotes for this particular shape. Well, first off, let's kind of try and understand what a hyperbola is. And we'll start with paper folding because I think it's kind of the most interesting of the constructions. So what I have here is a circle with a point C for the center of the circle and E representing a point outside the circle, and then a point F on the circle. Now, what's important about point F, and D here changes the size of my circle. So what's important is this black line between them that you see kind of do its weird thing there. That represents a fold between F and E. So if I were to fold that circle between the point F and E perfectly, I would create this crease. Okay, so as I move F around the circle, GeoGebra is going to create a crease. So I'll go ahead and start here. And so I'm folding all along here, folding a whole bunch of times. And it's creating a set of tangent points that form this shape of a hyperbola. So if you follow this curve in and back around, that is that shape is a hyperbola, and you've got a set of them there. And what's kind of neat about this is as E gets closer to C, we'll move it in here really close to the circle and close to the edge of the circle, you'll notice that as you start folding again, now your hyperbola is narrower. So I'll just keep kind of swinging F around. And you got a pretty good, pretty tight or narrow set of hyperbola there. And those 2 points are its foci. Okay, so what are those foci used for? Now before I move on, let's kind of review the ellipse. If I move E inside of that circle, and so you got C and E there inside, notice what happens. Let me clear it out. Now I'll move F around. It should form an ellipse where C and E are your foci. So again, that's still a perpendicular bisector between F and E. Alright, so let's move this a step further and look at the definition. So here I have a hyperbola where I can change the size of A and the size of B. I'll keep them positive. And I'll show you what A and B stand for in a minute. And then H and K just shift it left and right, or the center of this, or up and down. Alright, so we'll just, and A and B, also these points, capital A and capital B, are the foci. So the definition of a hyperbola is if I put a point from A to the hyperbola, and then a point from that hyperbola part to B, and subtract those two distances, I'll get a constant. So I've set that up. And let me show you. So there's point C, and I've created a line segment from A to C and C to B. And so, as I highlight D, you can see that AC is that distance, 6.22, and E is that CB there, which is 2.02. And if I subtract them, you get F, which is 4.2. And you can kind of see that. It says number F is the absolute value of D minus E. And so you kind of ignore everything else in here for now and just concentrate on F, D, and E. So I'm subtracting those D and E, and notice it is always 4.2 no matter where I'm at. Now I'll shift C to the other side, and it's 4.2 no matter what. Now let's change the hyperbola in some way. So let's make A and B maybe a little smaller so it's narrower. And let's move it so we can get a little better picture of it. And notice now my F is 7.2, D is 7.46, and E is 2.26. So if you subtract those D's and E's again, you should always remain with 7.2 with this new hyperbola. So I'll shift it over to this other side, and you can see that it is indeed 7.2, no matter how I move that. And that's the definition of a hyperbola. is those distances from those two foci, when you subtract them, there'll always be some constant, depending on the shape of your hyperbola. So enough of that. So, if you're trying to pass that algebra test, be nice to understand that kind of stuff. But let's just get to the guts of this thing and learn how to graph it. Now, any GeoGebra would graphs this thing without having to know what's going on really. But it's nice to know the vocab. Really, I'm going to teach you the vocabulary of a hyperbola. So by this time, you've already talked about all the other conics. If you're talking about hyperbola, you've already done ellipse, you've already done parabola, circle, and now we're on to hyperbola. So hit pause and see if you can determine which equation is which. Which one's parabola, which one's hyperbola, which one is ellipse. And if you notice, there's not much difference between any of them. And here's the key to this. You're going to have to know how to do this. So let's hit pause, see if you can figure out which is which, maybe whatever you can tell about it, and then hit start again. Okay, so what you have here, let me turn the microphone so you can hear me hopefully. So what you have here is this first one. Since it is x squared plus 4y squared, and there's a plus between them, this one is an ellipse. The second one down here, notice you only have a 4y and an 8y, which you could add together to make 12y, and an x squared. This is a parabola, and in particular, this particular parabola would open up or down, depending on how it's solved out. In fact, it's going to open, it looks like down. Okay, this one here is a hyperbola, or a parabola as well. So this was a parabola. This one's also a parabola. So this particular parabola, since you would solve for x, is going to open right or left. So this ellipse might look like this ellipse might look like this. It actually is down, opens down. And this ellipse is going to be either open left or right. In this case, I'm pretty sure it opens left. And then your bottom one, notice you've got an x squared and a y squared again, but the sign between them is negative, and that's what makes it a hyperbola. So you can almost ignore everything else but those. And that's going to be the trick. You're going to have to judge that for yourself. So when you come across one of these, you got to decide, is it a parabola, is it an ellipse, is it a hyperbola? Then you can go to work on it once you've just determined what it is. Okay, so that brings us to what is how do we graph one of these things, and what do we have? So, and I'm going to make this one kind of a quick video. The center of this one is going to be always at the origin for now. And so this is the general form. And I'll do another video when it's not at the origin. And you could have two forms. You could have this, or you could have this. And I think it's easier just to see real life examples, but that's the two general forms you'd have. And so, so let's say you had something like this, maybe x squared over, and they're not often put in nicely like this for you, but let's say you had x squared over 25 minus y squared over 4 equals 1, and y squared over 20, let's use different numbers. 36 minus x squared over 9 equals 1. So let's take a look at these two hyperbola. Now the first thing I would do is to get graph paper. That's the first thing to do here. And so what we're going to do here, these are at the origin. And so this 25 here tells me that we're going to go, since it's underneath the x squared, we're going to go right and left 5. So So we'll go ahead and put that in there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the 4 under the y says we're going to go right or up and down too along the y-axis. So 1, 2, and 1, 2. And we're not actually going to build our hyperbola. We are going to build our hyperbola, but what we've just created is the scaffolding to graph that. And so I'm going to draw a box that encompasses these axes numbers. And then you draw diagonal lines between them. The reason you put the box is so that you can put your diagonal line between them, and that represents the asymptotes of your hyperbola. So, you might go look up what an asymptote is, but in our case, it's going to be where the hyperbola almost reaches but never quite touches. And so then the last thing to determine here, the next last thing, is x squared is positive. So I know this asymptote opens to the right and to the left. So I know generally this asymptote, or this hyperbola, not asymptote, this hyperbola somewhat looks like this and like this. If you can imagine those paper folding hyperbolas we did earlier. And so that is essentially my hyperbola without getting into too much detail in it. And then your foci, those 2 points that we were finding before, can be found by adding the 2 and just take the square root of 25 plus 4, which is the square root of 29. Okay, square root of 29 is about 5.4. So from your center, which is here at the origin, you go right 5.4, which would be, well, about right in there, and left 5.4, and I'm kind of overlapping everything, I apologize. But that is where your foci lie. And the reason it goes right and left, not up and down, is because, our x squared was positive. Now, if you look at the other side, and we also want the equations of our lines. Well, this of our asymptotes, I said we'd also find that. So the equation of this asymptote, notice my slope is 2/5. So this is y equals 2/5 x. And this one is the negative of that, negative slope of that. And so that equation for that asymptote is y is equal to negative 2/5 x. So you might have to bone up on a little linear algebra for finding the equations of lines. So that's the equations of those two lines. So let's see if we can do the same with this. Or maybe you want to pause the video and give it a shot yourself now. So in this one, we're going to go up and down 6, since the 36 is under the y. So right here, and I ran off the screen a little bit. Oop. I'll move it down. Right there. And then right and left 3, since that's under the x. Okay, build your box, or your scaffolding, I call it. Draw your diagonals to represent your asymptotes. If you want to find the equations now, it would be a good idea. So this particular equation's y equals, well, you rose 6 and ran left 3, so negative 2x, and we're up 2 over 1. And this equation's y equals positive 2x, 6 over 3. And so that takes care of that. Since the y leads, you'd open up and down, because I'm running out of time. And your foci is the square root of 36 plus 9, which is the square root of 45, which is about equal to 6.7. So you go up 6.7, down 6.7, and that's your two foci. And that is the nuts and bolts of a hyperbola. More to follow. So hope this helps you. Good luck, and see you next time.